Hello everyone. So today I'm going to discuss about the section formula, which is a part of coordinate geometry. And here we'll be seeing that what is section formula and how we can apply to solve questions. As already we have discussed about the distance formula and the basic concepts of coordinate geometry in our previous class, let's start with the section formula. So first of all, what is section formula? Here in the section formula, it says that the coordinate of a point Px, y, which divides the line segment joining the points A, x1, y1 and B, x2, y2 internally in the ratio m is to n are mx2 plus nx1 upon m plus n, my2 plus ny1 upon m plus n. So this is how we can find out x and y coordinate of the point in this case. Now let's see how we can prove it. So to prove it, here what we are going to do is we will first list out the values. In this case we know AQ is equals to RS, which will be equals to x minus x1. Then if you talk about the value of PC, the value of PC which will be equals to ST, which will be equals to x2 minus x. Next, when you talk about the value of PQ, so PQ will be equals to y minus y1 and the value of BC, that will be equals to y2 minus y. Now, if we check if we'll check in triangle PAQ and triangle BPC, what we observe is that angle PAQ will be equals to angle BPC and angle Q equals to angle C, which is 90 degree. So by similarity criteria of triangle, we can say that triangle PAQ is similar to triangle BPC by A criteria, which implies we can write that PQ upon BC, which will be equals to AQ upon PC, which will be equals to PA upon PB. Now, if you substitute the value here, so PQ will be y minus y1 upon BC, the value of BC is y2 minus y, which will be equals to AQ, that is x minus x1 upon PC, the value of PC is x2 minus x, which will be equals to PA, which is m upon n. Now, if you will take two ratios at a time, then what we observe is that here, if we'll take x minus x1 upon x2 minus x equals to m upon n, we will get nx minus nx1 equals to mx2 minus mx. Now transposing m and n terms to one side, we'll get nx plus mx equals to mx2 plus nx1 will be equals to m plus n into x equals to mx2 plus nx1, which can be written as x equals to mx2 plus nx1 upon m plus n. Similarly, when we'll take y minus y1 upon y2 minus y as m upon n, then on solving we'll get ny minus ny1 equals to my2 minus my, which will be ny plus my equals to my2 plus ny1, and we can write it as y equals to my2 plus ny1 upon m plus n. And this is how we can find out the values of x and y. Moving to the next part, we are going to discuss about the midpoint formula, which is a special case of section formula. So in case of section formula, if the ratio becomes 1:1. So in this case, if we have a line segment, this is A, B, and now this time the point P is suppose the midpoint of A and B. The coordinate of A is x1, y1. The coordinate of B is x2, y2. So what we observe here is the ratio is 1:1 as P is the midpoint. So here m:n will be 1:1. We know that x equals to mx2 plus nx1 upon m plus n will get 1 into x2 plus 1 into x1 upon 1 plus 1, which will give x1 plus x2 upon 2, and y will be my2 plus ny1 upon m plus n. So that will become 1 into y2 plus 1 into y1 upon 1 plus 1, which will be y1 plus y2 upon 2. So this is how we can find out the midpoint formula using section formula. Now next one is another application of the section formula is how we can prove a quadrilateral is a parallelogram. We have seen earlier that we can prove a quadrilateral is a parallelogram if we can prove that its opposite sides are equal and diagonals are not equal. But we have more easier way when we know about the midpoint formula and the property of parallelogram. So here in this case, if you draw the diagonals AC and BD, then what we know in parallelogram that diagonals of a parallelogram bisect each other. So that means if I talk about the ratio of AO is to OC will be 1:1, and also the ratio of OD and OB will be 1:1. So we can use the midpoint formula. So in this case we can write that since O is midpoint of AC, therefore the coordinate of O will be equals to x1 plus x3 upon 2, y1 plus y3 upon 2. Then since O is also the midpoint of BD, therefore we can write the coordinate of O as x2 plus x4 upon 2, y2 plus y4 upon 2. Now since we are talking about point O and one point cannot have two different coordinates, so we can compare their coordinates. So on comparing, what we get is x1 plus x3 upon 2 equals to x2 plus x4 upon 2, and y1 plus y3 upon 2 will be equals to y2 plus y4 upon 2. On solving, we'll get x1 plus x3 equals to x2 plus x4, and y1 plus y3 equals to y2 plus y4. And this is the relation using which we can say that a quadrilateral is a parallelogram without using distance formula concept. Now let's talk about the questions. So the first question is find the coordinates of the point which divides the join of -1, 7 and 4, -3 in the ratio 2:3. So remember that before you solve these type of question, ensure that you draw the diagram. So here we have, suppose we'll take A as -1, 7 B as 4 comma minus 3, and there is a point, let the coordinate of P be x comma y, which divides it in the ratio 2:3. We have to find the coordinate of P. So we'll use the section formula, and we can write here x equals to mx2 plus nx1 upon m plus n. Here m is to n is 2:3. So if you substitute here, we'll get 2 into 4 plus 3 into minus 1 upon 2 plus 3, which will be equals to 8 minus 3 upon 5, which is 5 upon 5, and that is 1. Now find out the value of y. It is my2 plus ny1 upon m plus n, which will be 2 into minus 3 plus 3 into 7 upon 2 plus 3, which will be minus 6 plus 21 upon 5, that is 15 upon 5, that will be 3. So therefore the coordinate of the point P will be 1 comma 3. Now one thing you need to remember here is, when we are multiplying the values, remember always we are taking ratio of one side to the coordinates of another, and same goes with the other coordinate also. It will be easier to understand and remember this way. Let's solve the next question, which is find the coordinates of the midpoint of the line segment joining 4 comma minus 1 and minus 2 comma minus 3. So to solve it, we'll use the midpoint formula. So we'll say let P equals to x comma y. So in this case, x will be equals to x1 plus x2 upon 2, which will be 4 plus minus 2 upon 2, that will be 2 upon 2, that is 1. Y will be equals to y1 plus y2 upon 2, which will be minus 1 plus minus 3 upon 2, which will be minus 4 upon 2, that is minus 2. Therefore, point is equals to 1 comma minus 2. The next question is find the ratio in which the line segment joining A 1 comma minus 5 and B minus 4 comma 5 is divided by the x-axis. Also find the coordinate of the point of division. So let's draw the diagram first. This is point A, whose coordinate is 1 comma minus 5, and this is point B, whose coordinate is minus 4 comma 5. We have to take a point. Let us suppose this is the point P, and in this case, since the point lies on x-axis, the point will be of the form of x comma 0. So let P equals to x comma 0. Now here we can find out the ratio using both x and y, but as in this case we know the coordinate of y for the point P, we are going to use that. So we know y equals to my2 plus ny1 upon m plus n. So y is 0. The ratio here it is m is to n. We'll take m into 5 plus n into minus 5 divided by m plus n. On cross multiplying, we'll get 5m minus 5n equals to 0, which means 5m will be 5n, and so m will be equals to n. That means here P is the midpoint of AB. And so now we can use the midpoint formula to find the coordinates of P. So what we'll get, therefore, the coordinate of P will be 1 plus minus 4 upon 2 comma 0, which will be minus 3 by 2 comma 0. Let's move to the next question, where it is given that if 1 comma 2, 4 comma y, x comma 6 and 3 comma 5 are the vertices of a parallelogram taken in order, find x comma y. So we'll take let A equals to 1 comma 2, B equals to 4 comma y, C equals to x comma 6, and D equals to 3 comma 5. As we know, for the condition of parallelogram, If it is a parallelogram, what we can write that since ABCD is a parallelogram, therefore here we can say that x1 plus x3 will be equals to x2 plus x4 and y1 plus y3 will be equals to y2 plus y4. So here x1 is 1 plus x3 is x equals to x2 is 4 plus x4 is 3. So this means the x will become 7 minus 1, which will be 6, and y1 is 2 plus y3 is 6, which will be equals to y2 is y plus y4 is 5. So the value of y will be 8 minus 5, that will be 3. So therefore we can write x is equal to 6 and y equals to 3. The next question is, find the coordinates of a point A where AB is the diameter of the circle whose center is 2, minus 3 and B is 1, 4. So let's draw a circle. In this, we know the diameter always passes through the center. So suppose this is A, this is B, and the center is O. As it is given, the coordinate of the center is 2, minus 3, and the coordinate of B is 1, 4. We have to find the coordinate of A. Let A equals to x, y. Now we know that since O is midpoint of AB, that means we can write 2 equals to x plus 1 upon 2, which will give 4 equals to x plus 1, and so x will be equals to 3. And minus 3, which is the y coordinate of O, will be equals to y plus 4 upon 2, which will be minus 6 equal to y plus 4, and so y will be equals to minus 10. Therefore, the coordinate of A will be 3, minus 10. Moving to the next question, it is given that if A and B are minus 2, minus 2 and 2, minus 4 respectively, find the coordinates of P such that AP equals to 3 upon 7 AB and P lies on the line segment AB. So in this case, if we'll take this is A, B and P some point lying on the line segment AB, the coordinate of A is minus 2, minus 2, and the coordinate of B is 2, minus 4. We have to find the coordinate of the point P. Let P equals to x, y. Now let's find out the ratio first. It is given that AP equals to 3 upon 7 AB. So here what we can do is we can write AB upon AP equals to 7 upon 3, which can be written as AP plus PB upon AP, that will be 7 upon 3, and we can write it as 1 plus PB upon AP, that is 7 upon 3, which implies PB upon AB will be equals to 7 upon 3 minus 1, which will be 4 upon 3. That means the ratio is 3:4. Now to find it out, what we'll do, x will be equals to mx2 plus nx1 upon m plus n, which will be 3 into 2 plus 4 into minus 2 upon 3 plus 4, which will be 6 minus 8 upon 7, which will be minus 2 upon 7, and the y coordinate will be my2 plus ny1 upon m plus n, which can be written as 3 into minus 4 plus 4 into minus 2 upon 3 plus 4, which will be minus 12, minus 8 upon 7, and so it is minus 20 upon 7. Therefore, P will be minus 2 upon 7, comma, minus 20 upon 7. In the next question, we have to find the coordinate of the points which divide the line segment joining A minus 2, comma 2 and B 2, comma 8 into 4 equal parts. So, to find it out, first draw the diagram. So here we have A whose coordinate is minus 2, comma 2, B whose coordinate is 2, comma 8. We have to find the points, suppose P, Q and R, such that the ratio are 1 is to 1 is to 1 is to 1. Now in this case, we can say that since Q is midpoint of AB, therefore the coordinate of Q using midpoint formula, it will become minus 2 plus 2 upon 2, comma 2 plus 8 upon 2, which will be 0, comma 5. Now since we have got the coordinate of Q, which is 0, comma 5, we can further find out the coordinate of P and R again by using midpoint formula. So we can say since P is midpoint of AQ, therefore the coordinate of P will be minus 2 plus 0 upon 2, comma 2 plus 5 upon 2, which will be equals to minus 1, comma 7 upon 2. Next also we can find out that since R is midpoint of BQ, therefore the coordinate of R will be 0 plus 2 upon 2, comma 5 plus 8 upon 2. That will be 1, comma 13 upon 2. And that's how we can find out the coordinate of the 3 points which divide it into 4 equal parts. Moving to the next question, here we have to determine the ratio in which the line 2x plus y minus 4 equals to 0 divides the line segment joining the points A 2, comma minus 2 and B 3, comma 7. So, in order to find this question, what we are going to do, we will just draw the line segment. This is A whose coordinate is 2, comma minus 2 and B whose coordinate is 3, comma 7. Now let's take a line which divides it into some ratio which we have to find. So line is 2x plus y minus 4 equals to 0. Let us suppose this point line intersected at point P whose coordinate is x, comma y. And the ratio here in this case will take it as k is to 1. Sometimes to make the question simpler, even we can take the ratio as k is to 1 rather than m is to n. Now let's find out the coordinate of P first before we try to find out the ratio value. Now in this case, we'll have x equals to k x2 plus x1 upon k plus 1, which will be 3k plus 2 upon k plus 1. The coordinate of y will be ky2 plus y1 upon k plus 1, that will be 7k plus y1, which is minus 2 upon k plus 1, which will be equals to 7k minus 2 upon k plus 1. Now we know that since the point P lies on the line 2x plus y minus 4 equal to 0, therefore it must satisfy the given equation. So we'll write since P x comma y lies on the line 2x plus y minus 4 equals to 0, therefore we can say 2 into 3k plus 2 upon k plus 1 plus y, that is 7k minus 2 upon k plus 1 minus 4 equals to 0. When we'll solve it, we'll get 2 times 3k plus 2 plus 7k minus 2 minus 4 into k plus 1 upon k plus 1, which will be 0, which can be written as 6k plus 4 plus 7k minus 2 minus 4k minus 4 equals to 0. On solving further, we'll get 6k plus 7k minus 4k. So that will become 9k, and this 4 and 4 will get cancelled. We'll have minus 2 equals to 0, which implies 9k will be equals to 2 and k will be equals to 2 upon 9. Therefore, the value of a ratio will be 2:9. So this is how we can solve these questions. And this is where we'll be ending our session today. Thank you everyone. Take care.